There we go. Okay, so that's the only exponent. Now we want to get each denominator equal to the LCD. One of them already is, the first one, right? This is already the LCD over here. For the second one, we're missing x plus 5, right? The LCD I have written here. For the second one, we're missing x plus 5. So what do? We have to multiply the bottom by x plus 5. And again, to keep everything algebraically the same, we have to do the same thing to the top. As you can see, that's what I'm doing. So we do the bottom and the top, and that's what we have here. Now, I did carry out the multiplication because, again, what's going to happen is, since we're adding or subtracting, you really want to carry that out because we're going to simplify. If we were multiplying these two instead of subtracting, you really don't have to carry out this multiplication. If you're multiplying or dividing, since we're adding or subtracting, you really have to though. So now for the subtraction, right? What do? Well, this was the first one. I just factored the denominator, so it looks like the LCD. Same thing over here. I mean, here actually, I'm using what we got here above it. Now we're subtracting, right? So the denominators stay the same. What happens to the numerators? We subtract the numerators, right? That's why I'm using parentheses here. Right? I'm using parentheses, and why is that? What's going to happen is this negative sign is going to have to get distributed, as you can see. That's what happens here. So what happens here then? We combine like terms, right? -1 plus 5, that's 4. I put it at the end. 5x minus 19x, that's minus 14x. Minus 4x squared stays here. So this is what we get. And we want to know if this is simplified. Okay. Well, what I did was, for the numerator, I did factor out 2, because you can see that negative 14 and 4, they have a common factor of 2. So I took that out, as you can see. And you could factor what's left, the minus 2x squared minus 7x plus 2. But again, we really don't have to, thanks to the factor theorem. In other words, the denominator, hopefully you can see this, that the denominator, for x minus 5 to be a factor of the numerator, 5 would have to be a root of it. Same thing with x plus 5, except instead of 5, it would be -5. So for x plus 5 to be a root of the numerator, the numerator would have -5 as a root. So let me say it again. For x minus 5, right? For this to be a factor of the numerator, 5 would have to be a root of the numerator. For x plus 5 to be a factor of the numerator, -5 would have to be a root of this. And does that happen? That's what these calculations show. It doesn't. So in other words, the numerator does not have 5 as a root, as you can see. It doesn't have -5 as a root either. So that tells us that x minus 5 and x plus 5, they're not factors of this. So this is simplified. I mean, you really could have, you could have tried factoring the numerator here. You could have, although I'm not sure if you can factor that. What you could have done also is tried the quadratic formula. And what you'll see is that the numerator, the roots of it, again, the roots are the solutions to this equal to 0. The roots of it are not 5 or -5. So by the factor theorem, this is simplified. Okay. Are there any questions on that? Yeah, I really hope that made sense. Well, Well, let's do another one then. So for this one here, this one's actually pretty, well, yeah, let's do this one. So here we have these two we're going to add. Okay. Well, let's factor these. Actually here, the first rational expression, 6x plus 1 squared, that's actually factored. You know, that's factored already. So all we have to really do is factor the second denominator here. That's easier than it looks. Mostly because 36 is 6 squared, right? And x squared is x squared. This is the same as 6x squared. Basic exponent rules. So in other words, this here, difference, is equal to this difference, which is actually equal to this. We have a difference of 2 squares, right? And we can factor that as so. Yeah, let me see if I can write out what I'm trying to say. Actually, you know what? Let me do it this way. I was going to write out in pen, you know, the PowerPoint pen or whatever you call it, but let me just insert it as a text box. That's just easier. Okay. All right, I'll do this. There we go. Hopefully this helps. This is basically what we're saying. This is basically what I'm using right here. Okay. You know, before with x squared minus b squared, a was 1. So that's what I'm using here. So now to get the LCD, we have the first rational expression with the denominator factored, right? This one's already factored. So what are the irreducible factors here? Well, we have 6x minus 1, right? And 6x plus 1, so we write those. Here, 6x plus 1 is the only irreducible factor. For the greatest exponents, well, 6x minus 1, the only exponent of that is 1. For 6x plus 2, we have 1 here. We have 2 here, so we use 2. So the LCD is this. 6x plus 1 squared times 6x minus 1 to the first, which is itself. All right, so I don't know if I'll finish this example, but basically, again, what's going to happen is I might have to finish this next time. But again, we got the LCD to be this, and we're going to use that to actually carry out this addition. You know, as you can see, we have to get the denominators to be the same. That is, we have to get them to be the LCD. All right, let me stop here because we have like a second left. So let me stop.